Scooby-Dooby-Doo, where are you? We got some work to do now. Scooby-Dooby-Doo, where are you? We need some help from you now. Come on, Scooby-Doo, I see you, pretending you got a sliver. You're not fooling me, 'cause I can see the way you shake and shiver. You know we got a mystery to solve, so Scooby-Doo, be ready for your act. Don't hold back, and Scooby-Doo, if you come through, you're gonna have yourself a Scooby snack. Scooby-Dooby-Doo, here are you. You're ready and you're willing. If we can count on you, Scooby-Doo, I know we'll catch that feeling.
Yes. What's going on, everybody? Welcome to the 7th episode of the Meetup Messaging and Streaming Switzerland.
Welcome, everyone. I'm happy you're here as well. I hope you enjoyed this start. We have actually only seen it some hours ago. It was also surprising us. I hope some of the nostalgia from the old times came up again. And now we're trying to mix that with the future. Kafka streaming, analytics in real time, the usual stuff that you see here.
So just let me get that screen thing right. That should be like that. So now, well, as Patrick said, we are very happy to have you here and hope everything is well with you and your loved ones. Now, just in case you missed it, we're talking English today. At least we try to, because today's talks will also be held in English. Now, speaking of the talks, let's just move over to our agenda and see what awaits us today. We have Peter Marshall here from Imply, who will talk about using Apache Druid on top of data streaming from Kafka. And Michal Stutzmann from Swisscom will talk about processing and ingesting data from different sources into a knowledge graph. Before we start, let me just quickly introduce the team organizing this meetup. That's me in the middle, Korhan, working for SBB. That's a Swiss Federal Railways, in case you're not living in Switzerland. And the wonderful Ceci and Patrick from Spout. That's the company on your side to help you get ahead in your Kafka journey. I'll just hand over to Patrick, please, Patrick.
Yeah. Ceci did intentionally not try to be here with video because I actually wanted to engage her in some conversation here, because she's actually the one, as always, was organized like 99% of everything here that you see, at least the awesome part. The chaos and everything that's not working, that's mostly from us. So everything is awesome. That's from her. Big thank you, Ceci. And next time, maybe you're also here and I can interview you next time.
So now let's just move over to some organizational stuff. That's recordings. This meetup will be recorded and shared across various channels. That's probably then an issue if you would like to show yourself with your cam, just to let you know that you've been recorded. At the moment, we'll collect questions using Slido, and I think also now in YouTube, and we'll be able to answer them at the end of the presentations. The link will be in the chat. The slides will be shared afterwards in PDF form through some channels. I think Patrick will just give us some information how that will work out. That was my part. I'll hand over to Patrick.
Yeah, so let's start right into our main course. Let's go to the first presentation. As a first presenter, we have Peter Marshall from Imply. Hi, Peter.
Hi, everybody.
He is a very professional speaker, enthusiast of real-time analytics, right? And you might know the product Druid. So Imply is actually the company behind Druid. So you might know it better from that angle. And I think Peter will probably going to explain everything himself, which with his very nice English accent. So thank you very much, Peter, for being here. And
thank you. You're very welcome. Thank you for inviting me. Okay, let's see if the technical things work. I'm just sharing my screen, everybody. Thank you very much for inviting me. I'm happy that I feel part of Europe again. I'm very, very happy about that at the moment. Okay, so my presentation today should take about 20 minutes. I'm going to try and get it through at about 15, so you have a chance to ask me any questions that you have. What I'm going to talk about is Apache Druid a little bit, talk a little bit about where Druid came from. If you're not familiar with Druid, the kind of people who are using it, the use cases it has, but then get into the guts of the matter, why Kafka and streaming processing, streaming engines are really important to everybody who's going to use Druid successfully. So who is this really handsome guy that you can see with this wonderful accent? My name's Peter Marshall. I'm a technology evangelist working in the community team at Imply. So I don't have to sell anything. It's fantastic. I get to do presentations like this. I've worked in IT for a long time, done lots of different things that are really quite boring, most of them. I do have a degree in theology. So please, if you are putting questions on Slido, please don't make them about eschatology or God or the Essenes or anything like that. That will have to wait until I come and see you in Switzerland, and then we can have some nice beer, and then we can talk about those kind of things. And if you have a Peloton, I'm on Peloton randomly this last week. So come and say hi to me, A Million Bytes. Yeah, follow me. Cheers. I'll see you on a ride. So what am I going to cover? A bit of the Druid story. First of all, this is a Gorse animation of GitHub commits. If you're using GitHub, go and look at Gorse. It's amazing. I think it's really pretty anyway. Druid is 10 years old now. Well, it will be next. We're celebrating a 10-year anniversary next year from when it was open sourced back in 2012. It incubated through the Apache incubator 2018, 2019. It's now a top-level project. Lots of really cool and passionate contributors from all over the world, from San Francisco to Sydney. I love it. I think it's really changed how and when people make their decisions, whether that's someone in a business or whether it's me on a mobile phone trying to understand what's happening with my energy service this week. It's because of people like you, because of data engineers, because of software engineers, because of the Apache way that Apache Druid is what it is today. People are having their decisions sped up. It's having data democratized. Their experience is more flexible. The kind of user interfaces that get built on Druid are that much more interesting and fun to use than databases I was familiar with 40 years ago. So where did it come from? It came from a company called MetaMarkets. MetaMarkets actually was acquired by Snap, as in Snapchat, which you may know a bit better than MetaMarkets. MetaMarkets was a Silicon Valley advertising exchange. Don't know how advertising exchanges work. Essentially, they have a whole load of advertising space that they offer up for people to bid on. The people who bid the most money get the advertising space. So it can be expensive if you're going to use an advertising exchange. You want to make sure all of the investment you're making in your advertising is well earned and you're getting something back from it. So it's very competitive. And the problem they had is the more successful they became, the more data they had. And the problem of this success meant that they had a massive growth in data and they couldn't get the insights from the production, from the actual advertising exchange itself, into people's front rooms where they could slice and dice it and understand what was happening. Instead, the pipeline that they had, which include things like Hadoop. Can we talk about Hadoop anymore? It had Hadoop in it, was very unscalable. They couldn't query very well. They couldn't ingest very scalably. They had data that was disjointed. They had event data and batch data in separate sources. You couldn't query it in one place. The types of queries you could run were very limiting because they were very expensive to run. They were taking hours to run. and it was very slow. The latency from production to the desk was massive. So they decided to do a code and component review. And there's a paper available on the Druid project site where you can read the full analysis that they did, different performance benchmarks, different architectural decisions. Really a really good paper to read. And they decided, like all of us would, I mean, you'd wake up one morning and think this, let's go and build a new database. So that's what they did. They built Druid at the time. You'll notice there's a registered trademark sign on this anymore now, because Apache Software Foundation, as we know, it's now Apache Druid. What does it do? It's there to give business users, to give software engineers, to give data scientists fresh data that arrives very quickly, that's broader, that's more complete, and it's domain independent. All sorts of data where you can do investigations and run queries on demand. If you look at the Druid project website, which I hope you do, you'll see it's defined as a high performance, real-time analytics database. And what they could build was this, and it looks quite old now. It's not angular enough. It was allowing people to slice and dice on lots of different dimensions, 30 of which were high cardinality dimensions, across billions and billions of events every month. And they couldn't build this user interface, this really hot user interface, as we call it, without having a database like Druid. Their data warehouses, their data lakes couldn't deliver this kind of user interface. After it was open sourced by MetaMarkets in 2013, just months after it was open sourced, the first adopter was Netflix. A couple of years later, by 2015, eBay, PayPal, Cisco, and Yahoo picked it up. And the next year, well, this is my logo slide. I can't get away from logo slides, but you can see the number of Silicon Valley companies in lots of different regions all picking up Druid and working with it. Tim Tully was the vice president of engineering at Yahoo when they started using Druid, and he said this about Druid. He said it can do very large OLAP-style processing on the fly in hundreds of milliseconds instead of pre-calculating everything. The performance is great. Some of the tables that we have internally in Druid have billions and billions of events in them, and scanning them in under a second. And I'll highlight 3 things about what Tim said to help us understand where you place Druid. First of all, it's OLAP style. That means it's all about statistical questions. We want to know mins, max, averages, standard deviations, all that good stuff. But we want to get those answers on the fly. So that means we're not going to use Druid for things that might take an hour or 2 hours to run, and we're quite happy if they took 2 hours to run. This is where you want an answer to that question in under a second. Finally, he talks about billions and billions of events. We don't all work in companies with billions and billions of events in them. Obviously, Yahoo do. The point here is that Druid is linearly scalable. So every single component of this distributed database that is Druid can be scaled up or down according to what you're trying to do with it. They didn't go and reinvent the wheel when they created Druid. They actually learned lessons from all of those data technologies we've been familiar with for 20 years. So from log search technologies, they decided to bring together that kind of real-time ingestion connecting directly to Kafka, the flexible schema, no fixed schema, and some text search capabilities. And from time series databases, they learned a very valuable lesson. So Jeremy Wolfel, who's at Target, said everything in business, if you think about it, is about time. So they embedded that right at the beginning. Druid brings together the ingestion you get from time series databases, time-based functions, and it partitions the data according to time as a primary dimension. Finally, if you're going to do statistics, for heaven's sake, use a columnarized database. So that's what they've done. They've got a columnarized element of the system. It allows for a more efficient storage, operations on compressed versions of data, and it's also what's used to distribute data effectively for parallelized query execution. So what you have when you put all these 3 things together into Druid, you get a very mature and scalable ingestion capability, many millions of events per second if you really need to, a very highly distributed query engine, scales to give hundreds of users all sorts of answers to statistical questions on demand, no fixed cube, and you get a very refined and optimized storage system. So you can't just put real-time data in there. You can also backfill and put historical data in there, true Lambda architecture. So that's the background of Druid. I'm now going to move on to a slide that was created by my boss, Rachel Podreski. So, of course, all of us are going to upvote this and say it's the best slide they've ever seen. At the top here, we've got use cases that what we call hot use cases. That's Druid land. And then we have cooler use cases represented here by, I'm told, a warehouse full of government cheese, which, as you can see, is in black and white to illustrate how terrible it is. Now, in those cold use cases, slow queries are okay. We aren't interested necessarily in data that's extremely fresh. The queries could take hours to run. They could be on older data that's maybe more than a week old. And because of that, we are actually going to use it by a small team within the business who is going to know the ERD inside out, back to front. They're going to be curating the data experience of the end users because it's more about thinking and dwelling on the past and thinking about things logically. Whereas making instinctive decisions or gaining understanding by exploration or by comparison of time periods, instant flexibility about what we can filter and what we can group by, all of that is the realm of hot use cases. Here we have a hot database with a hot user experience for really hot users. We're thinking about queries that occur in sub-seconds, data that's as fresh as possible, really cool, exciting stuff that means lots of people are using it every day. And that means we have to have a database that scales to give us high concurrency and that allows us to build user interfaces that are highly interactive. So the user experiences that get built on top of Druid, of which there are many, are very personalized, interactive, very intuitive. They provoke people to make instinctive decisions, but we don't leave it there. We can't leave people to be thinking, oh my God, there's a spike. What do I do? We also have to give them historical data as well to allow them to reflect on the past. And we have to expand the audience of that analytics experience. What plugs into Druid? Druid connects natively with things like Grafana, Looker, Tableau, Metabase, and Superset. Some people build, just use the query APIs, a native SQL API, in order to build React and Angular applications. And data scientists might use it as a speedy database to do very quick analysis. There's also tools by Facebook called Prophet and one called something I've completely forgotten, one that does predictive analytics and one that does anomaly detection using the data that's in Druid. If you'd like to learn a bit more about the user experiences that get built on top of Druid, I've got this blog post. It's on the Druid forum, which is druidforum.org. There's a post there written by someone called Peter Marshall. I don't know if anybody knows who that is, where I kind of explain, after Virtual Druid Summit last year, a bit of a meta study of the kinds of things that people build once they have Druid in place. Why does streams matter to Druid? Lots of people will go and use Druid and plug it into an S3 data source, and they'll just use that for exploring the data. But the cool stuff is when people build things like this, when they build a geyser for their data that's hot, where the experience at the top is the ones we're talking about, the really cool ones that we all like to play around with and slice and dice and pull data all over the place. And it's all instant, no apply button, no save button. And in the middle, there has to be an engine that is built specifically for that purpose, where we can ask flexible questions, where we can scale the data volumes out, where we've got good APIs, where we can have lots of control over retention, about data tiering, where we've got good parallelization scaling, and where all the data underneath it is optimized specifically for building these hot user interfaces. That's great, but it means that we have to feed this thing with jet fuel. It has to be fed by something like, I don't know, Kafka or Kinesis or maybe Pulsar, where we can give people the data that they need specifically for this end user interface, and which protects this dream of very low latency from production to the end user where they're sitting, and that gives us facilities where we front load a lot of the stuff that we would usually just let the query run for hours and we don't care. We want to front load as much of that as we possibly can so the user is not aware of the amount of computation that's actually had to happen in the background. So I'll give you some example architectures. Druid typically sits after your data lake or message bus. It's the analytics engine that drives these user experiences with real-time and historical data. So we might pull it from MySQL or Postgres, we might pull it from S3, might pull it from Azure. Oh, yawning, yawn, yawn, yawn. What we really want to do is pull it in from Kafka and Kinesis, those streaming sources. And for that processing, we need to think about things like Apache Spark, Flink, KSQL, K-Streams, and we may manage that with Beam. Here's an example from a research journal. Please go and have a look at this. It goes into a lot of detail about this particular pipeline where they're reading data from IoT and sensor devices, pushing it through NiFi and Kafka through a beam control Flink pipeline, storing that in Druid and allowing discovery on a data science level and research level by end users. This is Netflix's pipeline. And yes, we've got it going through Flink and it ends up in Amazon S3 and we've got a touch of Iceberg in there just because. But notice that blue arrow. It goes direct from Kafka into Druid. That's the magic. That's the geezer. A similar one is at Flink, who's an Uber competitor in North America. They have a fantastic talk from Virtual Druid Summit. Please do go and have a look at that. Their pipeline looks like this. And I'd like you to notice just two different lanes here. First of all, there is a lane that has Druid in it. That's the hot user experience. But we also have a lane with Presto. Now, you might not use Presto. You might use Trino, some other kind of data warehouse. They're for the more complicated things, the things that we're okay and happy with that they take time. Druid, though, we're putting this in front of users who need answers now, where the queries need to execute extremely quickly. If you'd like to see some other things people have written about how they're using Druid, there is a tag section in Druid Forum. You can just go in and click on the tags and see whether they're using it with things like protobuf or some other weird format. Stream processing is really important to Druid pipelines. I've just selected a few here. It may be that to build this user experience, you need to think about things like this. One very important one comes to, for example, sessionization with clickstream data, where you can't give people session data immediately because the sessions might not have finished yet. So you need to do something upstream to keep an eye on the sessions and emit those when they're necessary. You might need to denormalize stuff so that, again, it's as fast as possible at query time. If you haven't heard of Apache data sketches yet, I believe they're probably one of the most important inventions in computer science in the last 10 years. Do go and look at them. They enable you to do extremely fast computations, things like count distincts, think about set operations, all with the advantage of approximation. So if you want to go and have a look at Druid, please go and have a look at the Druid project site. There's a quick start. You can just download Druid to any environment that has a Java runtime, go through the quick start guide. Ask us any questions about that when you go through that experience. There's the Druid user forum sponsored by Imply. There's the Druid meetups across the world. There's the Druid professionals group on LinkedIn. And of course, follow Druid itself on Twitter, Druid.io, and the hashtag Apache Druid. And that's me. Thank you, everybody. Time for questions.
Nobody hears me. That's good.
That's better.
That's good. That's good. Sorry, I have two locks on my mic, a software lock and the hardware lock, just to make sure that nothing escapes this room until I want it to escape. So sorry. Ceci, I think that you have prepared and collected probably the questions that came over our different path. Could we have them? So.
Oh, okay.
First question from Roberto. If you feed all events into Druid, how do you handle schema changes that evolve over a long time?
Okay. So I mentioned that Druid has time as a primary partition and it kind of learning from time series databases in that way. Each of the different partitions that are created at ingestion time refer to particular intervals that's configurable. Each of those intervals has an independent schema. So as the schema of the underlying data changes, it changes over time along that timeline with Druid. And then the query engine itself is intelligent enough to make sure that if you address one field that's in one period and it's not in another one, it'll give you a consistent result.
Cool.
It also has support for schema registries, I should say. That's the other thing we support.
Actually, oh, next one. Anonymous. Does Druid work with Microsoft Power BI? Did you expect this one?
I did, actually. So the reason why I have a bit of a funny voice is because I was at Big Data London yesterday, and I did have this question a lot. So Druid exposes its query interface via an API, which is SQL-based. It's an Apache Calcite interpreter, actually, and also via JDBC. So I have seen people trying to get that to work through Power BI, but not natively yet. I'd love to have a connector for Power BI, but don't tell my bosses that.
I think that a lot of our customers would have had exactly the same questions. Yeah. Anything else? Yes. So there is one. What are the most relevant drivers? Oh, that's a sophisticated one. Drivers for the importance of real-time analytics for regular enterprises. Probably that means in Switzerland, like not the big scale millions or hundred thousands of employees, but like some thousands of, I guess.
Yeah. Do you mean like normal companies that aren't Yahoo? Yeah.
Yeah, exactly.
So I guess that's how can I answer that question? I would say that it's that Druid and streaming technologies in general all have to answer that exact same question. And if there's a situation where someone says, do you know what, I think we need to think about using Kafka, then my natural next step is to say, how are you going to analyze that data? And me, Peter Marshall, is going to turn around and say, really, you should be using Apache Druid for that. So no, I'm kind of giving you a politician's answer to that question. And I would love to spend more time talking to you about it. But I would say, if you find the use case for real-time analytics and real-time streaming, you need real-time analytics as well. Was that a terrible answer? So sorry. Well, so I can tell you that that I think Druid 022 came out maybe even this morning, and Gian, who's the chair of the PMC, gets this question a lot. Who knows? I'd love it if next year, 10th anniversary, Druid 1.0 would come out. I'm just putting that out there into the ether. But yes, I don't know the answer. So I can't technically know, but there are talks by Netflix, as I mentioned on the Druid forum. If you go into that tag searcher, there are talks where I got that information from. Those talks will tell you exactly how they've implemented Iceberg and where it sits in their pipeline. If memory serves, there was a meetup very recently with Netflix, where the Druid community and we're talking with Netflix, and in there they did go into a bit more detail about the Iceberg part. There's quite a few people who are using Iceberg, actually. It's quite an interesting area.
That's incredible. We never had so many questions.
Oh, that's good. That's good.
You catch the audience. How do you achieve exactly one? Oh, exactly.
Okay.
That's a streaming question.
Yeah. So the topic offset is, so I should say, first of all, Druid is just using a standard Kafka consumer. So it's monitoring the topic offset based on each topic that it's consuming. And then it has a lock at the end of its ingestion process. So unless the data has been successfully ingested and successfully distributed through the cluster, it does not update the topic offset. So it guarantees exactly once semantics, just standard good Kafka practice.
Cool. But maybe one last one, if there is still one. There is. What does this do differently to the other DBs?
I have a whole talk on that one. Succinctly, I would summarize it like this. Druid is not a query engine that's executing directly on the data lake. So that has advantages, it has disadvantages. An advantage is that because it's architecturally close to the actual engine. It's actually inside Druid. The data is inside Druid. It means that we get these speed advantages. We can have secondary indexes. We can do good query parallelization, query optimization, lots of caching, all that kind of stuff that happens. So, and that's just the Druid architecture, whereas something else like Trino, for example, has different advantages. Maybe we federate our data sources. Maybe we don't have to have a fixed schema at ingestion time, et cetera, et cetera, et cetera. So for that one, I'll have to come back and do another talk in more detail. But yeah, it's not a query engine sat on a data lake.
Awesome. Thank you very much. I think there are even more questions. Let's see if we get a little bit of time at the end.
Yeah,
so cool. we have some more air for more so another talk. Thanks for the very hot talk, Peter, about hot data. From the first serious evangelist, I think, that I've ever seen with a real degree in theology. So I hope I can have a view with you in the future.
My mother is very, very happy, but I will have to tell you that story another time.
I have also to say I got a compliment from our CFO, which usually does not really listen to these talks, and she says that it was quite fun to.
Good, thank you.
So that says a lot, right? So thank you very much. And our next guest is Michal from Swisscom. We're going to listen and learn about the challenges that happen when you work with real-time data and graph databases. And they're doing awesome work at Swisscom. I'm sure Michal is going to tell you exactly what's going on, and I think he can do that much better than I do. So thank you very much, Michal, and you have the stage.
Great. Hello, everyone. I'm Michal. Let me just share my slides. Hopefully you see them. I'm working with Swisscom, with a team that is building a system to help to gain an end-to-end view of our services that we run. Swisscom is the largest telco operator in Switzerland, and we run all sorts of services like wireless, wireline, clouds, and so on. And so all these services have to be monitored. Let me get quickly to the agenda. This is going to be mostly a field report of how we are doing things to build this graph in real time. I'm going to talk about the problem we are actually solving, a little bit about the vision, and then I'll go into architecture to show how things are connected. Then we delve a bit into data models, so the topology and alerts. This is the exact data that is ingested into the graph. Then we are going to talk about how exactly the graph is built in a streaming fashion. Then I'm going to talk about the ingestion presentation layers of the system, a few words about the automation that we do, and some challenges and takeaways. Okay, so as I said, Swisscom is a telco operator, and here you can see say a typical scenario. We have a customer, we have a business customer that has several services delivered, several products. Here on this in this image, you see 5 services. So on the left side, there will be some connectivity service. Then there's going to be, so the customer could have several, say, locations across Switzerland. There will be connectivity to the internet. There's going to be some cloud products, so applications for this customer running in the cloud. All of these services are separate, but somehow interconnected, because to get to the cloud, you have to have the connectivity service first. You have to have the access to the internet, and so on. So when you run a service like this, you have to manage a lot of components. And as you see here, the connections between these different products go through the network. The network is complicated, it's multi-layered. There's going to be access network, core network, different virtualizations across. And so monitoring it, seeing if there's actually a problem in the service is complicated. To complicate things more, there is never a single system to monitor everything. There's going to be different local service or network management systems run by separate teams that are really focused on one part of the network. So for example, here there's going to be a team responsible for the access network or for the cloud infrastructure, for the core network and so on. And they are responsible for running their service, so they have proper management and monitoring tools. They can do root cause analysis if something goes wrong, but they rarely have the knowledge about what could happen in other parts of the network if they change something. There is also at the top the support of the operation control center that answer calls from customers, and they have to, if something goes wrong, they have to quickly see what's going on. And usually this process takes some time. They have to contact specific teams if something is really wrong. So to ease this, we are now working on a new system that could basically make this process of getting this full view much quicker. So what's the vision? So essentially, we could get all this information into one place, into one single knowledge graph from different parts of the network, connect all these things together and give an end-to-end view of what is going on with a specific service. Of course, it isn't practical. It's actually impossible to sort of create one single management system for the whole network. So the vision, the idea here is that there will exist this small local management and monitoring systems for different parts of the network, but they should share information. They should share alerts and the inventories to the central place. So then this knowledge graph can be built out of this information and show the relations, the dependencies between different services, different networks. In addition to that, if we add on top customer information and what the customer, what services are configured, what agreements are signed with the customers and so on, we could get additional data to provide proper customer impact propagation. So we could, based on this graph, we could see that if one part or one router in one part of the network is down, this and that customer could be affected. Another good use case is to identify the causing area. So basically, if something goes wrong, we could quickly pinpoint in which area the problem is and relay this information to proper team. Because we are not building a central management system for the whole network, we have to get this information from all these local management and monitoring systems. And the idea is that we get specific alerts from them, so they are responsible for defining the alerts. And in addition to them, we get topology information. So the exact network entities, or say services or nodes that are connected to these alerts. So let me dive a little bit into the architecture of the system. So this is a typical data aggregation or ETL pipeline with it's different because it's streaming, it's real time. It's important to be real time here because the graph is used by the support people, so they have to have real time information about what is going on in the network. Here on the left side, you see different Kafka topics with the data coming from these different local management systems. A good thing about Swisscom is that we are actually also a big data company in a sense, because there exists Swisscom big data platform with huge data lake, and all these network management systems and monitoring systems are already integrated with it, are integrated with Kafka and are producing data to Kafka, which can be used then by us to ingest into our system. Usually the data comes from several Kafka topics for each producer. So there could be a management system with several tables in the database. They all will be produced to Kafka as separate topics, and they all come together. So in our ingestion pipeline, we have to handle the correlation or the joining between these different data streams. Of course, the cleansing, correlation, filterings, joinings, and so on. Then all this data is ingested into GraphDB. We use Neo4j for that. And we also have a UI for presentation where we implement different use cases for different user groups at Swisscom. Let's talk a little bit about the data model. So as I said before, the idea of this global end-to-end monitoring system is to get specific data from each of these local subsystems. And this data is alerts or events and related entities. So here in this diagram, you see an alert, and say this alert happened on a specific service or on a specific node in the network. So you get this alert plus this entities as a small subgraph. On the right side, you can see all the different types that we support currently in the graph. And this could be a service node, or we also ingest tickets from ticketing platforms like incidents, problems, changes. We also have the customer information. This information, of course, doesn't contain any alerts. This is only inventory data, but this model supports that as well. You just don't get an alert; you just get the topology. So let me quickly explain how we ingest this data to the graph. So here you see we get a stream of these little subgraphs, and we basically merge them together. So here you see 3 messages, 1 to 3, and the resulting subgraph would be a merge of all these little subgraphs. Now, this is data that comes from a single local management system. But the main idea of this global graph is to connect data from different producers. And this is where the complexity comes. So essentially, you have 2 streams of these little subgraphs, and you have to find the correlation between different entities. So we call them joins. And while we ingest all these 2 streams, we have to find these links between 2 subgraphs and also connect them in the graph. We don't merge actually the same entities from 2 different streams. We create 2 and link them with so-called is-same relationship. This is to avoid the complexity of merging strategies and so on. So how the ingestion layer works. So we get these messages from Kafka, and we have 3 ways of ingesting this to the graph. We use simple message transformations. This is this was the first method that we used. This is for very simple sources where we actually get the information almost correctly formatted in the desired sort of way. Then if we have data that has to be joined together, so for example, for two different producers, or maybe from the same producer, but from 2 different tables, then we also have to provide joins, and these joins are implemented with as Kafka streams applications. Then for very complex use cases, we also adopted KSQLDB, and I will tell about it later in the talk. For ingestion, we use just plain Kafka Connect sync connector. Yes, so the simple message transformations. This is quite simple. So we basically just apply the transformation and ingest back to Kafka. Then the connector ingests this little subgraph into a Neo4j. Then for the joins, we have to somehow correlate these 2 different streams. So we have another application, Kafka Streams application, that produces this same as relationships from these 2 message streams, and another connector that ingests to the graph. Then for KSQLDB, essentially KSQLDB could at some point replace all these other transformations. However, it's still quite new, and we're still experimenting, but with very good results. And for example, for ticketing systems, we ingest tickets with the work logs, relationships. We parse attachments in different formats using UDFs in KSQLDB, and extract relationships between different entities. So quite good experiences. However, we also hit the wall several times. So for example, this parsing of attachments, we actually work with byte streams. This is possible only with the latest version of KSQLDB, where the byte support has been added. Now the most complex thing I think we have been working on is the deletion of data. There are several options. This is actually something that we're still working on. So I'm just sort of enumerating the options now. But what you can do if you have to delete the data. So currently, we just ingest everything and it stays there. But the options you have is to set some kind of TTL. This is possible in Neo4j. We can also compare the previous with the latest and the previous version of a subgraph and try to figure out what has been deleted. This, of course, requires keeping a state in Kafka Streams app store. Or we also get explicit deletion requests from the upstream in the form of tombstones or soft deletes. This also has to be handled. So there are many different cases, and all of this together adds a lot of complexity to this ingestion layer. Now, some summary about this ingestion layer. So we currently have 15 pipelines from 15 different producers in the network, 12 joiner app deployments, 3 KSQLDB headless deployments, all running in real time without any buffering windowing, because this is the main requirement of the system. Ingestion throughput to 2,000 messages per second is not a lot. But as I said, the complexity lies actually in sort of managing this different pipelines, the joining, and so on. Now the size of the graph we currently have is around 100 million nodes, 150 million relationships, and 250K is-same relationships between these different source systems. We run Neo4j Enterprise Edition with 3 replicas, and each about 100 gigabytes. All of this fits in the memory, so the query performance is quite good. Now, a few words about the presentation layer. What use cases we have to support? Usually, when a customer support agent logs into our system, the first point of entry is a customer name, or maybe a node name or a service name. So we have to provide a full text search capability, but Neo4j is not extremely good at it. So we have added another Elasticsearch cluster where we do replication of the whole graph. And then we essentially, when the user inputs something into the search field, then we first query Elasticsearch, we find pointers to the graph, and then we query the graph, retrieving all the rest, the information, and present it to the user. In this UI, we actually serve these different use cases like impact propagation, causing array identification. Let me tell you a bit more about this impact propagation. So what we're trying to achieve is, when we have a customer, we look at all the services the customer has, look at where these services are, all the dependencies between the services, on which physical nodes they are running, and if there are any alerts from the monitoring systems that we ingest. So in this example, you see there is an alert on the node on the right side. This means that the service is impacted by some problem, and the customer is also impacted. Of course, this is very simple graph. Usually we have several layers, and sometimes actually the query performance could be very low to retrieve this. For the UI, we have the one main UI and plus 2 dedicated portals and around 100 users. This grows the system. We are still building the system, developing further, and it's getting more and more attention. So that's it. You might ask, how we manage all this. I mean, there's so many pipelines. So we essentially adopted the infrastructure as code principle. All the pipelines are configured in the Git repository. We have special Ansible plugin to work with the Swisscom big data platform to easily deploy everything where it needs to be deployed. We use Customize for Kubernetes deployments. So essentially, a one-click deployment is possible, but for any component that manages state, this is always complicated and has to be evaluated first. So what's the sort of the current status? What have been the challenges and takeaways? So we are operational. We provide this service already to the customer support in some sort of beta version. It's in constant development. We keep adding new data sources, new management systems, new inventories, and so on. This is actually the major challenge. This is where we spend the most time on, to actually understand the network behind the dependencies, how connect all these pieces together. Swisscom is a large company, and there's no a single place of knowledge where you can get all the information. So you have to go out, ask people, ask engineers, understand, and talk to your users and bring everything together. So that's the major challenge. During fast development, sometimes we actually break the graph, we break the model, and we have to reload everything from scratch. This usually takes a lot of time and resources. So we try to avoid this, but this is usually, we have to have this in mind when doing changes. We also constantly work on improving the actual use case, the impact propagation, for example, to take into account redundancy in the network. So if you have two components serving on which the service runs, if there's redundancy, we don't have to mark it as impacted, for example. Query performance on Neo4j, this is also a constant thing we look on. And we also do user research and UX work in the end. So this is really a full stack development here. So that's all I have for you today. I'm happy to take your questions. Thank you.
Same thing again. So thank you very much, Michal, for this awesome presentation. So how long have you been working at Swisscom on this project?
So the development time is already around 1.5 years, 2 years, almost 2 years. And this, as you've seen, this has been a greenfield project. So we started from scratch, evaluating the technologies to be used. And yes, that's the answer.
Cool. So let's see if there are any questions from the audience. Ceci, could you maybe? Yes, there was one. So for Michal, how are your experiences with Neo4j in production?
We run a three-node cluster of Neo4j Enterprise, and the only real issue that we had was with transaction memory for ingestion. But sometimes you essentially get an exception when your insert is too large. This can be configured now, so that's how it has been solved. There's query performance. I mean, this you always have to look at the details, look at the query plans, optimize your queries, and this kind of things. But no major issues so far.
Thanks. I was told that it's not Ceci putting the questions, but Sabine. So thank you very much, Sabine. Is there a next one? Yes. Ooh, a long one. Louis said, you noted that you use Neo4j in the middle for the presentation. You use Elastic. Why did you choose to use these intermediate DBs and not access directly on Neo4j?
So Elasticsearch is used only for full text search. It's the only use case. So because Neo4j is very slow at that. So we always go first to Elasticsearch and look for pointers in the graph, and then we ask Neo4j for getting the topology from that point. And we combine this data together. So it's only performance reason.
Cool. Another one. Is there a risk that for a breaking change in Swisscom infrastructure, the graph can have inconsistency?
Yes, that's true. So we, as I said in the presentation, we ingest all the changes, but we currently don't do any deletion. So the lack of deletion could give you the inconsistency in the graph. There's also other issue that I didn't tell you about. Essentially, when you have two streams of data, there might be some kind of race condition, especially if you do reloads. So essentially, say nodes or relationships suddenly disappearing or appearing again, and so on. And we are also addressing this issue now with an additional component that would put order into it.
Cool. So I was made aware that we are running out of time. So I think there are some few questions left, and we will forward them to you and Peter so you might answer them asynchronously. Corey, do you think we could have the last few slides?
Of course,
Well
they're on their
done.
way. Yeah.
Thank you very much. Thank you very much. So Scooby and Shaggy, I think it's Shaggy, right? Shaggy are happy. Thank you very much, both of you. These were really awesome talks. Let's wrap it up and go to random awesomeness because we do have some last few points that we would like to add. First of all, we have introduced something new, the job board. And we were so badass to actually use it first. So the thing how this works is I propose that anybody in the community that is looking for people that want to work in the streaming field can just drop us an email, a link, and we'll add it here to the board. So we as a company, let me introduce this new feature. We have 2 open positions, both focused on streaming. So if you're either a junior or a senior, we would be looking very much forward to have you and having a talk with you. So if you have a job, an opportunity that you would like to publish here, I repeat, please write us at mission@spout. So we would love to add it here as well. If you want to sign up as a speaker, we have a new form. It's on Meetup. Please just sign in there, and you can fill out all the details. We are looking forward to have you. We have had really awesome talks, and I'm sure you have lots of more. And then there is one other thing, even more awesome, a survey. I know you love surveys, so please fill out this one as well. Why? Because we want to get better, we want to learn, we want to see what you like and what you dislike about what we're doing. What topics are you interested in? Where are you on your journey to learn streaming? We want to know that, and please let us know, because we will listen to you and we will really adapt the talks and try to get close to what you want. So, and there's one last thing, the Scooby-Doo moment. I don't know how many of you really remember the series, but if you do, you know at the end it will end with somebody pulling off the cap and then seeing who was the bad guy. It was the pony, and that's a short preview of the next day. Our next meetup. It will take place already in a month. Because we have so many applications for talks. Thank you very much for this. 28th of October, before all the Christmas stress starts to slowly rise, we will have ponies and awesome talks. And please be there. We are both, all of us, really looking forward for you. So thanks again, Peter and Michal, for your awesome talks. Thanks, Ceci, for preparing everything. Thanks, Sabine and Gaetan for helping us on the technical side, because I think everything went smoothly. That was the first. I think we never had that. So thank you very much. And I'm looking forward to have you again. Corey, last word.
Thank you very much to everyone. And it was nice to have you here. Have a nice evening. Bye-bye. Take care.
Ciao.